working on mixed numbers and fractions. The first problem says write the mixed number as an improper fraction. So I have 7 2 over 3. So the first step is to go back and change it into improper. How do I do that? 7 2 over 3. I multiply 7 times 3, which is 21, and I add 2 to it. So that's going to be 7 times 3 plus 2 over 3. That would give me 23 over 3. Change or write the improper fraction as a mixed number. Now how do I do that? I'm going to divide 75 with 4. Now I could do it so many different ways. I could see how many times 4 goes into 75, but I'm going to break it down for you. The first thing I'm going to do is I'm going to check 4 goes into 7 how many times? Only once. So 1 times 4 is 4. The remainder is 3. I bring down the 5. Now 4 goes into 35 how many times? 8 times. 8 times 4, 32. Remainder 3. How would I write this? Now this is the question. So the answer would be 18 3 over 4. How can you cross check? When you multiply 4 times 18 and add 3, you should end up with the 75. Write the fraction in simplest form. There's so many ways of working this out. Usually they go for the greatest common factor, and some of them cannot find the greatest common factor right away, so they try to break it down with simple numbers here. So you can pick any number you want. You can pick a 3, you can pick a 2, you can pick whatever number is convenient to you, and check if that number goes into both 24 and 21. Alright, 24 and 21. So here, when I look at 24, the number I'm thinking about is 6. So 6 goes into 24 4 times. And remember, the same 6 has to go into 210 as well. So 6 goes into 210 35 times, because 6 times 35 gives me 210. So the least common, so the simplest fraction here is 4 over 35. If 6 did not come into your mind, what can you do? Let's go ahead and work it out. 24 over 210. So I'm going to think, when I look at these numbers, I'm thinking 2. 2 goes into 24 12 times. 12. And now the same number 2 has to go into 210 as well. So 2 goes into 210 105 times. Alright. Now you might be asking me, but your numbers are not same as mine. I've definitely, the first one, 4 over 35 is not same as 12 over 105. Why? Because we can reduce it further. So the next number I'm thinking about is 3. 12 goes into 3 4 times. 12 goes into, 3 divides 12 4 times, and 3 divides 105 35 times. See, you might take a couple of more steps if you pick a different number, but you will ultimately get the same answer. The next one is negative 42 over 70, negative 42x over 70. So the question is, what number are we picking here? What numbers can you pick? So I'm going to give you a minute to go ahead and think, what numbers do you think will go into 42 and 70? The number I'm thinking right now is 14, the number 14. So 14 goes into 42 3 times, so I end up with negative 3x. 14 goes into 70 5 times. And again, you might not be thinking 14. So what do? You pick the smallest number. I usually see students picking number 2. That is fine. So let's go ahead and work it out with number 2. 2 goes into 42 how many times? Negative 21x times. 2 goes into 70 how many times? 35 times. Do you see a number that goes into 21 and 35? I see a 7. 7 goes into 21, negative 3 times. I bring down the x and the 5. 7 goes into 35 5 times. Find the prime factorization of the following number. So prime factorization is you're going to pick the prime factors of number 84. You can start with any number. I'm going to pick 2. 2 goes into 84 42 times. I'm circling my prime. 2 is a prime. 42, you can either start with 2 or you can either start with any other number you think of. I'm thinking 42 is 6 times 7. 7's a prime. 6 is 2 times 3. 2 is a prime. 3 is a prime. If you circle that number would not be factored because it's a prime number. So now I can rewrite 84 as 2 times 2 times 3 times 7 in increasing order. Or, because I have two 2's, I can say 2 squared times 3 times 7. Perform each indicated operation and write the answer in simplest form. They're asking us to divide. When we divide fractions, what do? We keep the first fraction, we change the second fraction, right? So this is going to be 4 over 4. 3 over 4 now becomes 4 over 3. And division becomes multiplication. There's so many ways of doing it. You can go ahead and multiply 4 times 4, which is 16. 4 times 3, which is 12, and then simplify it. Or I would always like to work with small numbers, so I simplify right here. 4 and 4 cancel each other, so I'm simply left with 4 over 3. Perform the indicated operation, and the answer has to be in simplest form. So let's go ahead and see what's going on here. We're trying to do negative 2 over 3 times negative 8 over 15. I would work the signs first. Negative times negative would give me a positive. And I'm going to see if I can simplify any numbers. I always like to simplify it right here. Remember, you can simplify one in the numerator, one in the denominator. Not both in the numerator or not both in the denominator. Okay? 2 and 15, no. 3 and 8, no. So let me go ahead and multiply this one. What do I end up with? 8 times 2, 16, and 3 times 15, 45. Remember, I already multiplied the numbers before, the signs before, so I'm good with that. So let me go ahead and work this out. This is 19 plus 2, 3 over 13. 19 plus 2, 3 over 13. There's so many ways of working it out. What students usually do, this is a minus sign actually, 19 minus 2, 3 over 13. What students actually do is they try to change this into an improper fraction, change 2, 3 over 13 to an improper fraction, work it out. Or there's one more way of doing it, which would be, I'm going to change 19 to 18 plus 1. 19 is 18 plus 1, correct? So 18 plus 1. Instead of saying a 1, I would do 11 over 11 minus 2, 3 over 11. See how I changed my fraction? Instead of 19, I made it 18, 11 over 11. What is 11 over 11? 1. 18 plus 1 is 19. Now I can do the fraction part and the number part separately. 11 minus 3, right? So I could work that fraction part, and then I could simply work 18 minus 2, another fraction part. There's so many different ways of doing it. So 11 minus 3 would give me 8 over 11, and 18 minus 2 would be 16, 8 over 11. The next problem. Remember order of operations, divisions, and multiplication. Many of you, when they say PEMDAS, P-E-M-D-A-S, they kind of think multiplication should be first and then the division. But that's not the case. And students go ahead and multiply first and then divide. That is not the case. You're doing PEMDAS starting from left to right. So for going from left to right, if you see parentheses first, you finish your parentheses. If you see exponents first, you finish exponents. So parentheses and exponents are like one group. And then going from left to right, if you have multiplication first, you do multiplication. If you have division, you finish your division. So multiplication and divisions are another group. Addition and subtractions are another group. So you finish your group 1 first and go back from left to right. finish your group 2, again go back left to right and finish your group 3. All right, so it doesn't mean multiplication comes first before division. So I'm going to go ahead and see if I have anything from group 1. Parentheses, exponents? No, I don't have any parentheses. I don't have any exponents. 2, do I have any multiplication and division? Yes, from left to right division comes first, so 1 over 2. How do I divide? Keep, change, flip, change, 3 over 2 times 3 over 4. See, I did the division part first. Now when I go ahead, now I see everything is multiplication. 1 times 3 would give me 9. 2 times 2 times 4 would give me 16. Simplify each complex fraction. There's so many ways of working complex fractions out, but I would like to work the numerator separately, denominator separately. All right, so let me go ahead and work with the numerator here, which is 5x over 7. There's nothing I can do about this one. So let me go ahead and check the denominator. 20 over x squared over 21. I'm seeing if I can simplify any of these. No, I can't. 21, I don't think I can do anything. Now, this is numerator over denominator. Or, I can say it's numerator divided by denominator. Let me write it in the second way. 5x over 7 divided by 20x squared over 21. And I see division of fractions. What do? Keep, change, and flip. Right? I can go ahead and simplify here. 7 goes 1 times, 7 goes 3 times. X goes once, x and x squared, I end up with the x. 5 goes 1 times, 5 goes 4 times. What am I left with? 1 times 3, which is 3. 1 times 4, which is 4. Do not forget your x here. X. All right. Solve. And again, so many ways of solving these. What I suggest students to do is bring all the x's to one side and all the numbers to one side. That is one way of doing it. Or you can make everything into a common denominator, work it out that way. Let me show you the first way. The first way is I am going to bring all the x's to one side and all the numbers to one side. So what I'm going to do is I'm going to subtract x over 4 on both sides, right? And subtract 5 over 12 on both sides. Alright, so let's go ahead and see what's going to happen now. So 2 over 3 minus 5 over 12 is equal to x over 2 minus x over 4. Remember, I cannot subtract until I have the common denominator. So this is going to be 3 times 4, 3 times 4. So 8 over 12 minus 5 over 12 is equal to, least common denominator of 2 and 4 is 4, so times 2 times 2. So 2x over 4 minus x over 4. So now what do I have? 8 minus 5 is 3 over 12 is equal to x over 4. What students usually do is they cross multiply. You can do that too. But remember, it's always nice to simplify. So 3 and 12 is nothing but 1 over 4. So I have 1 over 4 is equal to x over 4. When you cross multiply, you get 4 is equal to 4x. Divide both sides with 4. Your x is equal to 1. That's one way of doing it. Or, when the denominators are equal, the numerators are equal. So 4 is equal to 4. X should be equal to 1. That's another way of doing it. Now, there's one more way of working this out, and I'm going to see if I can squeeze that in here. What I would like to do is I would like to make the whole denominators 12. So I have 2 over 3 plus x over 4 is equal to 5 over 12 plus x over 2. The least common denominator of everything is 12 here. Times 4 times 4 times 3 times 3. This is already a 12 times 6 times 6. Now what do I have? I have 8 over 12 plus 3x over 12 is equal to 5 over 12 plus 6x over 12. All right, so, and again, so once I have this, I'm simply going to pretend that I don't have a denominator because I have the same denominator throughout the fractions. I'm simply going to cancel it. So now I have 8 plus 3x is equal to 5 plus 6x. I subtract 3x from both sides and I subtract 5 from both sides. What do I end up with? I end up with, let me see if I can squeeze this right here. I end up with 3 is equal to 3x, so x is equal to 1. It's another way of doing it. Whichever way is convenient to you, you can go ahead and follow that way. So what I did in this way was I made everything into a common denominator. Once I have the same denominator, I cancel it off, and then it's a regular equation without any fractions. So you bring all the x's to one side, all the numbers to one side. Negative 3x over 8 is equal to 3 over 4. There's so many ways of doing this one also. You can cross multiply and then work it out. Or I like to simplify here. I like to simplify. This is another way of doing it, one of the ways of doing it. So simplify the fractions. The denominator 4 goes into 4 once, 4 goes into 8 twice. So I simplified this fraction to 3x over 2 is equal to 3 over 1. And again, I see that I have a 3 and 3 in the top. 3 and 3 cancel. So I have negative x over 2 is equal to 1 over 1. Now I can go ahead and cross multiply. So negative x times 1 is negative x. 1 times 2 is 2. But I'm not looking for negative x, so I'm going to multiply both sides with negative. So I end up with x is equal to negative 2. Remember, you can work with the denominators only if it's a proportion. Work with the numerators only if it's a proportion. What is a proportion? Two fractions must be equal to one another. Now you might be asking a question, can I do this here? Is this a proportion? Not yet, because of the plus sign. See, this one didn't have a plus sign, but this one does have a plus sign. So I cannot go ahead and cancel these two 5s. I cannot because of this plus sign. I should have one fraction, like in this case, equal to exactly one fraction, like in this case, for me to simplify the denominators and the numerators. Okay, now let's go ahead and solve this one. X over 5 plus x over 1 is equal to negative 24 over 5. Again, I need to have common denominator times 5 times 5. So this is x over 5 plus 5x over 5 is equal to negative 24 over 5. So I see I have the same denominator throughout the equation. So you can either multiply both sides with 5 this way. In this way, you can simply cancel off the 5s here, or you can simply cancel it off without multiplication, either way. So x plus 5x is 6x. That is equal to negative 24. Dividing both sides with 6, x is equal to negative 4. Find the perimeter and area of the figure below. So let me go ahead and fill this up. If this is 2/3, this is 2/3. If this is 1, this is 1. So I'm adding 1. Perimeter is simply adding all the sides. 1 plus 1 plus 2/3 plus 2/3. So you end up 1 plus 1 is 2. 2/3 plus 2/3 is 4 over 3. So there's so many ways you can, if you want to change it into an improper fraction, you can change it into improper fraction and then work it out. So this 4 over 3 is what? When I change the 4 over 3 to improper fraction, I get 4 over 3 as 1 over 3. So this is 2 plus 1 plus 1 over 3. That gives me 3 1 over 3. And this is the perimeter. How do I find the area? Area is simply length times width. So this is simply 1 times 2/3, which is 2/3. Remember the units. It's feet times feet. So it's going to be feet squared. So this is going to be your area, and this is going to be your perimeter. This is again your feet. All right, let's go over the next problem. A carpenter cuts a piece 3/4 feet long from a cedar plank that is 6.5 feet long. How long is the remaining piece? So he has 6.5. He cuts 2/3, and I'm checking how much do I have more. Fractions, fractions, numbers, numbers. So these two fractions, they don't have a common denominator, so I need to make them a common denominator. So least common denominator of 2 and 4 is 4, so it's going to be 6. 2 times 2, 1 times 2, -2, 3/4. So when I rewrite this one, I have 6, 2/4, and -2, 3/4. But if I go ahead and multiply, I can't take away 3 from 2. What do I need to do? I'm going to get a negative number. That's not possible. So what should I do? I borrow 1 from 6. So 6 now becomes 5. And where do I put the 1? Do I just put it in front of the 2? No. When you borrow 1, you add the denominator. So 2 plus 4 is now going to be 6/4 minus 2, 3/4. Let me repeat what I did. I can't take away 3 from 2, so I borrow 1. When I borrow 1, I just don't add a 1 here. I add the denominator to the numerator. So it's like 2 plus 4, which is 6. And now when I go ahead and subtract it, I end up with 6 minus 3 is 3/4. 5 minus 2 is 3/4 feet is left out. All right, let's go ahead and work the next problem out. In this problem, I am subtracting 8 over 15y, -2 over 15y. It's not a multiplication or division of fractions, so definitely I need to find a common denominator. Remember, only multiplication and division don't need a common denominator. Everything else does need a common denominator. So I'm going to go ahead and look at the denominators. 15y, 15y. I hit the jackpot. They are the same, so I don't have to worry about finding one. 15y, -8 minus 2. -8, -2, or you can say -8 minus 2, they're all the same. It's like you're going 8 steps back and again taking 2 steps back. So you end up with -10 over 15y. And wait a minute, your answer should always be in simplified form. So I'm going to simplify this with a 5. 5 goes in 10 2 times. 5 goes in 15 3 times. So my final answer would be -2 over 3y. Remember, the y has to stay with the 3 because it's in the denominator. If you give me your answer as -2y over 3, that would be totally wrong because the y started with the denominator, so it has to end in the denominator. All right? The next problem would be 9a over 10 plus 2 over 5. In this case, I definitely need to find a common denominator. So here, I'm going to rewrite this 9a over 10 plus 2 over 5. The least common denominator of 10 and 5 is 10. So times 2 times 2. So this now becomes 9a over 10 plus 4 over 10. Now, do I have a same denominator? Yes, I do. So I'm simply going to have it as 10, 9a plus 4. Can I add 9a and 4? No, because one is a variable, the other is a constant. So this is going to be my final answer. Next problem, 7x over 9 plus x over 9. an addition, I'm going to look for common denominators. Again, I hit my jackpot. They already are common denominators, so I don't have to go ahead and find one. So it's simply going to be 7x plus x. 7x plus x ends up with 8x over 9, and that will be your final answer. Let's go ahead and add 3 7 over 8, 7 2 over 5, and 2 3 over 4. I'm going to write down the fraction parts first. So 7 over 8, 2 over 5, 3 over 4. I'm just writing down the fraction part. And remember, it's an addition, so when I add, I need a common denominator. I'm looking at the denominators. One is 8, one is 5, one is 4. I can't add them, I need a common one. So what's the least common denominator of 8, 5, and 4? In here, I see a 40. So 4 times 10 times 10. 5 times 8 times 8. 8 times 5 times 5. Remember, whatever you do to the denominator has to be done to the numerator. So now these fractions can be rewritten as 35 over 40, 16 over 40, and 30 over 40. Alright, so now do I have a common denominator? Yes. So when I go ahead and add them, 30 plus 35, 65, 65 plus 16, I would get 81 over 40. And 81 over 40 is an improper fraction, so I can change that to a mixed number. So when I divide 40 with 81, 40 goes into 81 2 times with the remainder 1 over 40. Now I'm going to go ahead and add this one to this one. So I'm just going to go back here, and so this whole fraction part becomes 2 1 over 40. So now I finish adding the fraction parts. I'm going to go ahead and add the numbers 3, 7, and 2, which gives me 12. And the fraction part was 2 1 over 40. So now when I go ahead and add them, I add the whole numbers, 2 and 12, which is 14, 1 over 40. Now, 3 1/3 times 6 3/4. When you multiply, you don't need a common denominator, so you can go ahead and multiply. But this is in a mixed number. I need to change it to improper fraction. So 3 times 3 is 9. So 3 times 3 is 9. 9 plus 1 is 10. So 3 1/3 now becomes 10 over 3. 6 3/4. 6 times 4, 24. 24 plus 3, 27 over 4. So I can rewrite my problem as 10 over 3 times 27 over 4. You can go ahead, multiply it, and then simplify it, or you can simplify it and then multiply it. I like to simplify it first and then multiply it. So 3 goes into 3 one time, 3 goes into 27 9 times. 2 goes into 4 2 times, 2 goes into 10 5 times. So 5 times 9 is 45, 1 times 2 is 2. You can go ahead and keep this as an improper fraction, or you can change it as a mixed number, either way or any way. Alright?